All right, let's pull back the curtain on the digital world and talk about something we have all experienced, the software bug. But we're not just here to complain. Nope, we are going on an insider's journey to follow the secret life of a bug, from the moment it's created to its ultimate fate. Let's dive in. So picture this. You're in the middle of typing a super important message, and poof, the app just crashes. Or maybe you're trying to click a button on a website and absolutely nothing happens. Yeah, if you're nodding your head right now, you are definitely not alone. It's got to be one of the most universal frustrations of modern life. Well, congratulations, you've just had a close encounter with a software bug. And today, we're actually going to treat that bug like a character in a story. We're going to follow its entire life cycle, from the second it's discovered, all the way to its defeat.
So, our bug story, it begins with the hunt. See, behind every single app and website, there's a team of software testers, or QA engineers. And their whole job is to basically think of all the weird, creative ways you and I might break things. You can think of them as detectives, hunting for these flaws before they ever get to us. So what exactly is a bug anyway? Well, at its core, it's any time the software just doesn't do what you expect it to do. I mean, that could be a massive screen-freezing crash, or it could be something as small as a typo in a button. If it produces an unexpected result, guess what? It's a bug. The moment a tester finds one of these bugs, it is officially born. But, it doesn't just get fixed instantly. Oh no. It begins a very formal journey, what we call the bug life cycle. This is the system that makes sure every single bug is tracked, judged, and handled the right way.
And here's what that journey looks like when everything goes right, what we call the happy path. A tester finds a bug and logs it as new. It gets assigned to a developer, who then changes its status to open while they're working on it. Once they think they've got it, they mark it as fixed. But it's not over. It boomerangs right back to the tester for retesting. And if the fix actually worked, it's officially closed. Case solved. But that's the happy path. What happens when the developer looks at that bug report and just disagrees? When they push back and say, hang on, that's not a bug. Well, this is where the human element, and let's be honest, the real drama, comes into play. And that little disagreement? It can lead some bugs to a totally different fate. Rejection. See, not every single reported issue actually gets fixed, and developers often have some pretty good reasons for saying no. So what are they? A rejection isn't just a simple no. It's really the start of a conversation. Not reproducible or need more information is basically the developer asking for a clearer report. Duplicate just means someone else found it first. An enhancement request is fascinating. That's where the tester sees a flaw, but the developer sees a brand new idea. And of course, that brings us to the most famous reason of all: works as designed. This has led to that classic kind of tongue-in-cheek line from developers you may have heard. It's not a bug, it's a feature. It just means the software is behaving exactly the way it was built to, even if that behavior seems a little odd to the rest of us.
Okay, so that's the life of one bug. But how do entire teams know if their whole bug hunting process is actually working? Well, they keep score. In the world of software, this means using metrics to turn the art of testing into a real science.
You can think of test metrics as the vital signs of a software project. They take this chaotic hunt for bugs and turn it into cold, hard data. It helps managers answer two really important questions. How good are we at finding these things? And maybe more importantly, are we ready to ship?
One of the most important metrics is defect removal efficiency. Honestly, just think of it like a batting average for the testing team. It's a simple question. Of all the bugs that were out there, what percentage did we find before our customers did? The closer you get to 100%, the better your team is at protecting users from those annoying flaws.
Now, on the flip side, you've got the defect rejection ratio. This one keeps track of how many bug reports from testers get rejected by developers. A high number here isn't really about blame. It's a huge signal that the communication between testers and developers might be breaking down, and maybe the reports need to be a little clearer. So, beyond the process and the numbers, what really separates a good tester from a great one is their mindset. They operate by a few core principles that guide every single effective bug hunt. One of the big ones is called the pesticide paradox, and it's a really simple idea.
If you spray the exact same pesticide on a field over and over, eventually the pests evolve and it just stops working. Software is the same. If you run the exact same tests again and again, they'll eventually stop finding new bugs. Great testers know they have to constantly evolve their attack.
Another key principle is defect clustering. You might know it as the 80-20 rule, but applied to software. Experience shows that a huge number of defects, like maybe 80% of them, are often hiding out in a small, really complex part of the code. Smart testers know where these little bug neighborhoods are, and they focus their efforts right there.
And this one. This might be the most important principle of all. Early testing. Finding and fixing a bug when the software is just a document, just an idea on paper, is incredibly cheap. But finding that same bug after the product is already out there with millions of users, that can be astronomically expensive. The earlier you hunt, the better. So, all of this leads to the central dilemma of software quality, right? If we accept that finding every single bug is pretty much impossible, then the real goal isn't perfection. It's about managing risk. The ultimate challenge for any team is one of judgment, knowing which bugs are just a little bit annoying and which ones are total deal breakers. And that is the essential art behind the science of the bug hunt.